Let's start with a new problem in calculus, which is to differentiate the function which is shown over here. The function that we have got is fx is equal to tan of sine x cube. So over here you can see sine x cube is in the argument of tan and x cube is the argument of sine. So we have nested functions, as you can already see. We have to differentiate this function with respect to x. Now clearly you don't know the formula for the derivative of this entire function, you haven't learned a formula. So we have to use chain rule in order to differentiate this. Let's see how we do it. So first of all, I write my function as it is, tan of sine x cube, and the first thing I do is I assume sine x cube to be t. This is quite similar to what we did in the last problem. So I can write derivative of fx with respect to x simply as derivative of fx with respect to t multiplied by dt by dx. Over here in this expression, I have simply multiplied and divided by dt. Now in the next step, I can put the value of tan sine x cube as tan t because I have assumed sine x cube as t. So this can be written as d tan t by dt multiplied by dt by dx, and the value of this comes out to be secant squared t, where t is nothing but sine of x cube. Now we have to tackle the problem of d sine x cube by dx. Now once again we don't know the formula for this, so we will again assume x cube to be a second variable, which is p. So if I assume x cube to be p, then I can write this expression as d sine p by dp into dp by dx. Once again, I haven't done anything but multiplied and divided by dp. This is exactly the procedure of chain rule as you would have studied in the differentiation video. So in the next step, I'll find the derivative of sine p, which is simply cos p, and the value of p is x cube. So cos of x cube multiplied by dx cube by dx. Now clearly this is a polynomial x cube, and the derivative for this will be 3x square. So my entire solution comes out to be 3x square into cos x cube into secant square sine of x cube. Now there's also a quick method to do it where we can skip the part of assuming a specific variable for a function. Let's see how to do that. So over here you can see I have to write the derivative of fx. I immediately write it as d of tan sine x cube upon d sine x cube multiplied by d sine x cube upon dx cube multiplied by dx cube by dx. So what I did in this, which is different from the last, is that I did not assume separate variables t and p, and I directly put the value of t and p as a function itself. So in the last example, if you want to go back and see, what we did was we wrote it as d tan t by dt. In here we wrote it as directly d tan sine x cube by d sine x cube. We put the value of t directly. Similarly, we have written d sine x cube by x cube. Over here we wrote d sine p by dp. So instead of assuming the variable, we are directly writing the function, and because over here we are differentiating this entire thing with respect to the argument function, I can directly apply the formula for sec. So once we have written it like this, we can simply put the value as secant square sine x cube multiplied with cos x cube multiplied with 3x square. Rearranging the terms, we will get 3x square into cos x cube into secant square sine of x cube, which is the final answer. I hope this process of chain rule is very clear to you, and this method will be used again and again during the subsequent chapters. Thank you.